Okay, Tessie remind me that I do not record, but so far we recorded. The last class I cannot record. This is no reason that we have no video. But this class is recorded immediately. I post it in YouTube, guys, in YouTube, no in Blackboard, in YouTube. In YouTube is easy. Okay, now subtraction. Subtraction is very, very similar. Look, subtraction is very, very similar because the only thing you should do is suppose it's the same number, no? And subtracting, when you remove the parenthesis, well, the minus m stay the same, but the subtract no, change the sign. Minus 2 plus I.
Professor, I can't see the screen for some reason. Like what you're writing down, I can't see it.
You cannot.
No.
Okay, let me see. Share screen. Okay, I select this as a screen, so the whiteboard to share with you. You see now or no?
No, I still because the thing is when I get out of Skype, like the little screen shows me, but I can't see a full. Right now I'm on the full screen and the only thing I see is you.
Okay, so I recommend you que you get up and restart again. That may be
Okay.
free. Okay.
Okay.
Now again we combine like term. 4 and minus 2 is 2, positive. Real part. Imaginary part 3i plus 1i is 4. Final answer. Easy. Piece okay. Addition and subtraction is super easy. The problem in the test I put one example of the addition and subtraction. Okay. Okay, multiplication. Multiplication is a little bit more complicated, not too much. Multiplication. Multiplication. Suppose que it's the same complex number. It's 4 plus 3i times 2 minus I. Okay, I enclose every complex number in between the parentheses and don't see any arithmetic symbol in between, but you suppose default que multiplication is time, period, invisible period, right? Entonces you consider que this is like a binomial, 1, 2, real part, imaginary part, and you apply for it. Different. You for it, like a binomial. We are doing an intermediate. You multiply 4 times 2 is 8.
Professor,
Uh-huh.
I just joined back, but I still can't see it. Oh, now I see it. Now I see it.
Okay, please don't interrupt me anymore, okay? Entonces 4 times 2 is 8. 4 times minus I is minus 4i. 3i times 2 is 6i. And 3i times minus I is minus 3i squared. Yeah? Leave it like that? No. You need to combine that term, and you need to remember that I squared is equal to -1. That we discussing this in the first lecture, no? So immediately you replace I squared is real by -1. So it's 8 minus 4i plus 6i plus, or plus no, minus 3 -1. Okay, actually, I realize que si I squared is -1, this negative, and this negative together become positive. But okay, no, let's do it step by step. 8 minus 4i plus 6i plus 3, because negative and negative together become positive. So 8 is real part, 3 is a real part, it's 11. Imaginary part, minus 4i plus 6i is 12. End the story. This is final. Now the only complication in the multiplication is that you have to remember that I squared is -1, and you replace. So no leave it like that. This is crazy. No, this is crazy. That because I squared is confusing, because I squared is no imaginary, it's real. However, multiplication have another important case in which you multiply any complex number time is conjugate. This idea of the conjugate is super important. What is conjugate? Conjugate is the same complex number, the same, but opposite sign in the imaginary part. So the complex number 4 plus 3i conjugate, the symbolic way to indicate conjugate is the bar, is 4 minus 3i. Suppose 2 minus i conjugate is 2 plus i. So the real part stays the same sign, but the imaginary part change. This is important. I want to explain now why, and the division is super important conjugate idea. Okay, I have no idea. Let me try to do exactly the same. Foil, you foil. Okay, you multiply 4 times 4, 16. 4 times minus 3i is minus 12. I. 3i times 4 plus 12. I. And plus 3i and minus 3i is minus 9i squared. Entonces, something interesting and amazing happened. The I disappeared. Always. Important conclusion. When you multiply any complex number times its conjugate, the answer you get always is real. No I anymore. This situation can happen here in this particular example happen always when you multiply this special product. So we have 16 is real, and this is also real, right? Because remember again, I squared is negative 1 and negative 1. So negative become positive. It's plus 9. This is okay. And this is 25. Wow. Important conclusion. When you multiply any complex number times its conjugate, the answer is always real. No I anymore. And the shortcut to determine or figure it out, this is super easy. You multiply first and first, okay, 4 times 4, okay, 16. 3 times 3, I don't care this I. This is a shortcut. No? Of course I care, but the shortcut, I don't care. You multiply 3 times 3, is 9. Always plus. Unbelievable is always plus. So in general. Suppose we have A plus IB. Time is conjugate. It's a special product. The answer is A squared plus B squared. Oh, amazing. I know I anymore. And you multiply this times this and this times this. And plus, no I. Okay, let me see if you understand or you don't understand. Suppose I bring 3 examples.
Excuse me, sir.
Please, what do you want?
I want to know if you took attendance yet.
Okay, let me present the example. In the example, you try a little bit more, okay?
Okay.
Okay, suppose. Okay, you multiply 2 plus I times 2 minus I. In this case, we discover, wow, is 2 complex number and 1 is a conjugate of this. Using the shortcut, you multiply 2 times 2 is 4. Always plus, look at that. And the coefficient here is 1, invisible, no? I don't care if it's positive or negative, it's negative 1. The answer is 5. Do you see that? Suppose another example. Suppose 1 plus 3i is a complex number times its conjugate, get 1 minus 3i. What do you suppose is the answer? Come on, help me. Help me. Please. What is the answer? Answer for the chat or activate the microphone temporarily. Come on, guys, for today. 10. Very well. because 1 times 1 is 1, always plus, and 3 times 3 is 9. Super. One more. 1 plus I times 1 minus I. What is the answer of this? Another participation. Come on. Help me. No idea? Totally lost? 2. Sabrina. Very well, Sabrina. Sabrina says 2. The answer is 2. Why is 2? Because 1 times 1 is 1. Always plus. And this invisible 1 and this invisible 1. I don't care if it's positive or negative. It's 1. It's 1. This is the formula, guys. The answer is 2. Super. Okay, so we are ready to discussing in detail division. Division. Let's do it one couple of the examples. Suppose you divide 4 plus 3i divided by 2 minus i. Okay, this is my original problem. I try to solve it. Entonces, figure it out. What is the answer of this? You always create, let me use another color, one guy here que is formed by the conjugate of the complex number in the denominator. This is 2 plus i. This is 2 plus i. We confront this. Well, we have two numbers, no? Top, bottom. Numerator, denominator. You take the number in the denominator, you find the conjugate, and you create something here. I call a smart one. Because I know very well that any number or expression divided by itself is 1, and 1 is invisible multiplier. So I create this, I know, I realize it doesn't affect my original problem because it's 1. But you multiply top, bottom, no? Let's do in the bottom part, it's easier because we create the shortcut. The answer is 5, no? I did before, no? 2 times 2 is 4, and 1 plus 1 times 1 is 5, no? And in the top, no, in the top, we can do by the traditional FOIL because they are not family. So 4 times 2 is 8. 4 times I is 4i. 3i times 2 is 6i. And 3i times I is plus 3i squared, no? Something like that. I never leave it like that, I squared. My recommendation, in my brain at least, I know okay, I squared -1. So immediately I replace. I never write like that. I erase mentally this I squared. Of course, this now is not positive, it's negative, and that's it. Okay, ready to combine. Real. 8 minus 3, 5. Imaginary, 10i. Divided by 5. Entonces, you divide by 5. It's not wrong, but it's no elegant. Express the answer like that. You split this common denominator, 5 over 5, plus 10 over 5, 10i over 5, and 5 over 5 is obvious que es 1, and 10 over 5 is 2. And this is the beautiful, elegant final answer. 1 plus 2i. Any question? Okay, entonces division is always the same. You create the smart one using the conjugate of the complex number in the denominator. One more example, 10 over 1 plus 3i. Exactly the same. The conjugate is 1 minus 3i. Top and bottom. And now multiplication. I did before. 1 times 1 is 1, plus 3 times 3 is 9. It's 10. Denominator is 10. It's real. And the top, well, it's easy. It's not necessary for the distributive property. It's 10 minus 30i. Entonces 10 minus 30i. Entonces now, guys, remember, you have to express it, the final answer, when you manipulate complex number in standard form. What means standard form? Real part plus I imaginary part. Okay, so you split this common denominator, 10 divided by 10, minus 30i divided by 10 is 1 minus 3. End the story, final answer. Okay, any question? It's easy, right? No. You have to practice. That is the reason the homework is waiting for you, no? No problem. You understand very well. Sure? Okay, I want to raise the board. Okay, let's practice now. Remember the last class we practiced power of I. Now let's practice power of I now again, but using negative exponent. Because in the test I don't know, see the exponent is positive or negative. Power of I, but in this case using with negative exponent, because we practice positive exponent, but no negative exponent. Okay, so now let's see. Suppose I to the negative 9 exponent. This is exponent. So you need to remember that negative exponent is the same of reciprocal. So flip it, 1 over I to the 9 power. You remember that? Yes or no? And the recipe is okay. The rest is 9. Remember 9 divided by 4, always divided by 4. Remember the last class is 2, is 8. Subtraction, remainder 1. Entonces this is equivalent to say 1 over I. Because I know that I to the 9 power is equal to I. And doesn't leave it like that? No. This is not the final answer. At this moment we are in front division. Division 1 gets real number and I gets imaginary. Purely real, purely imaginary. And you apply exactly the same conjugate. Minus I. Because I, you can interpret like a 0 plus 1i. I is a purely imaginary number, right? We have no real part and we have one imaginary unit. And the conjugate of I is 0 minus 1i, que es negative I. Okay, let's do it. Entonces, super easy. Multiplication 1 times negative I is negative I. And I times negative I is minus I squared. But I know que I squared is negative 1, and this negative 1, and this negative 1 together become positive 1. So in the top is minus I, and the bottom we have 1 positive. Okay, because it's negative together become positive, it is positive 1. And divided by 1 is nothing, so the answer is not negative. Do you follow me or you are totally lost? Follow me or lost? Come on, guys, answer me.
I'm lost.
Lost. What part is lost?
Everything.
Everything. Okay, guys, this is a stupid question because when you answer me or when you ask me, you need to a specific question. What part you don't understand? But I cannot help this question. I don't understand anything. I cannot help. Okay, let me try another, and let's see if you understand, Mr. or no. Okay, I raised to the negative 13. Okay, we are doing power of I using negative exponent. When the negative exponent is reciprocal. Do you understand this? It's 1 over I to the 13. Okay, do you understand this or no? Yes, and the Angelica Gonzalez, yes. The rest of the students is yes, you understand this? Reciprocal, negative exponent, reciprocal. Okay, great. After that, I focus it in I to the 13. 13 divided by 4, like in the last class. Es 3, es 12, remainder 1. Entonces, I discover que 13 is equivalent 1 over I to the 1 power, que by the way, 1 power is invisible. This one, where I come from this one? This one is this one. Okay, you divide it by 4 and take the remainder. Always, yes, I explained the last class, Angelina. Always divided by 4. Always divided by 4. The reason you divide by 4, remember, I proved that the partner is repeated 4 by 4. So this is the reason you divide by 4. Now division. Okay, thank you. Okay, now we face the problem of the division. And remember the division, you create the smaller one using negative I, negative I. Entonces 1 times negative I is negative I. And this I did before this is minus I squared. Y I know que minus I squared is positive 1, no? Because I squared alone is negative 1. And double negative becomes positive. Entonces the answer is minus I divided by 1, que 1 is invisible, multiply and divider. And the answer is just negative I. Any question? No. And the student that don't understand anything, understand now, clear or no?
Yeah, that's me.
Yes. Go ahead.
So anything, if I'm understanding this right, I don't know. You tell me. Anything with a negative exponent, you can convert
to
with
positive.
a positive number on top, which is a 1.
Absolutely. Yes, you're right.
Correct. Thank you so much.
No, my pleasure. Okay, guys. One more of this or enough? One more or no? It's supposed to be enough, right? Okay, let me see now the last operation in the complex number, que es a power. Suppose, power. Pero power of the no i's, power of the arbitrary complex number. Suppose power operation is, suppose que you have 2 plus 3i square. Okay, 2 plus 3i square is equivalent to say 2 plus 3i times itself. The problem is que the exponent is not 2, es 3, entonces es too long. Because you multiply 2 plus 3i times another 2 plus 3i times another 2 plus 3i. It's not complicated, but it's too long. And that's I never put the exponent 3, 4, 5. No, it's only 2. Okay. So this is similar. You foil. 2 times 2 is 4. 2 times 3i is 6i. 3i times 2 is 6i. Again, repetition. It's obvious because they are twin brothers, no? And finally is plus 9i squared. 3i times 3i. And remember, I squared is negative 1. So immediately I know that. Fine. Erase this. Just put negative 1 here. Because, remember, one more time, I squared is negative 1. Okay, ready to combine. Lighter. This and this together is the real part is minus 4, minus 5. Imaginary is 12. Final answer. Any question? Easy, eh? One more similar, but it's a little bit confusing because I want to use an irrational number. Because at least I know that you are aware that the situation could be happening, no? So sometimes it's a whole number, integer number, easy, pretty easy, but this is ugly. But that's what I'm saying. That you multiply radical 2 over 2 plus I radical 2 over 2 times itself radical 2 over 2 plus I radical 2 over 2. Let me multiply radical 2 over 2 times radical 2 over 2. Okay, let me copy here in the corner of the board. because this multiplication is repeated 4 times, ¿no? Entonces radical 2 over 2 times radical 2 over 2. Es obvio que radical 2 times radical 2 es 2, ¿no? Because it's radical 4. And radical 4 is 2. And 2 times 2 is 4. And 2 over 4 in lowest term is 1/2. Wow, 1/2. So any product here that we are doing is 1/2. Radical 2 over 2 times radical 2 over 2 is 1/2 positive. Real. This and this together is imaginary. It's 1/2 I, no? Right, the same reason. This is, again, 1/2 I. And the last one is 1/2, but minus, no? Because it's I squared. And remember, I squared is -1. Now ready to combine like term. Real, positive half and negative half. Wow, it's 0. Cancel out. And 1/2 plus 1/2 is 1. The answer is just I. Because 1 is invisible, no? 1 I. And when there's 1, you know, the algebra start omit. Suppose default when the coefficient is 1, it's invisible. The answer is I. Unbelievable, but it's true. The answer is just I. Any question, guys? Okay. No question, Sabrina. Sabrina understand very well. Okay, guys. Let's move on to another topic. No more for a moment, no? Complex number. And let's go to the super important part, que es the quadratic equation. Guys, quadratic equation is super important because we see every day. Today, every day we solving at least one quadratic equation. Quadratic equation. Quadratic equation expressed in standard form is something like that. Look, ax squared plus bx plus c equal to 0. So it's standard when the right hand side must be 0. Not always happens. So you need to manipulate in order to express it. So to start the solution for the quadratic equation, you put in standard. It's the first step. And A, B, and C are coefficients that in general are real number. Okay, A, comma B, comma C are in general real number. But it's important that A no 0. No 0. Because A is 0, suppose que this is missing. Entonces dice no quadratic. O sea, the category que classify que dice equation es quadratic is because A exists. Okay? See, B maybe is missing, no problem. Stay quadratic equation, and C is possible missing, pero A no. Okay? Okay, entonces we studied today 3 different ways to solving the quadratic equation. The first one is called square root method. Square root method. And it's very important or popular when method when B is 0. Now when you have B 0 and that part is missing, in my opinion, it's the easy way to apply the square root method. I want to explain 1, 2, 3, 4 example. Look. Suppose x squared minus 4 is equal to 0. We compare. Look, ax squared plus bx plus c equals 0. This is the general. It's obvious in this specific example, a is 1. Because the coefficient here is 1. B is 0. Wow, B is missing. That is the reason I prefer using the square root method. And C is -4. Okay. What's the idea for the square root? Super easy. You isolate the x squared, similar to what we are doing in linear equation, and you apply now square root both sides. And square root cancel out each other. It's just x. And square root 4, I know it's 2. Very important, important, important. We have two solutions, plus and minus. Don't forget, please, plus and minus always when you apply square root method. Solution set. Solution set is two solutions, no? Plus and minus 2. We can write like that. Or we can write like that. 2 positive and 2 negative. The order is not important. Two solutions. Entonces, I strongly recommend using the square root method when the b is missing because it's super easy. Do you follow me? Do you understand this or not? Let me see another example. No. Yes. Okay. John Martinez says yes. Suppose another example 2 of the square root method. Suppose this. Okay. I realize b is 0. So I want to apply square root method. You isolate x squared equal minus 9. Apply square root both sides. And x is equal, but now square root negative 9 is imaginary, right? Remember, when you have a quantity, negative quantity inside the radical, the answer is 3i. 3i because square root negative 9 is square root 9 times square root negative 1, and this is 3, and this is by definition is I. And don't forget plus and minus always. So the solution set is plus and minus 3. I am the teacher, and in order to emphasize what is the solution, I write solution set SS. But you are a student, and suppose you are doing like that, and you enclose in the box here. I understand very well that your answer is good. Okay? Let's see 2 more examples, a little bit more complicated and interesting. Suppose this. X plus 9 squared plus 16 equal to 0. In this case, not necessarily b is 0. Because if you expand this binomial and you combine that term, you get the classical quadratic equation and b no 0. However, I take advantage that somebody, not me, do the factorization, that part. I try to isolate the square part, the power 2 alone. I move 16 to the right hand side, and you apply now square root. It's similar. A square power and a square root cancel out each other. It's just x plus 9. And the square root negative 16 is 4i. And don't forget plus and minus. Finally, so for x, I move 9 to the other side, minus 9 plus and minus 4i. In this case, guys, we have 2 solutions. It's complex number, no? The real part is negative 9, and we have the conjugate. Because normally when the solution of the quadratic equation is complex, the solution complex is coming by pair of conjugate. Okay, it's negative 9 plus 4i in this case, comma, negative 9 minus 4i. Solution set. Okay, conjugate. They are conjugate, yeah. Always happen that situation. Suppose now, last example, p plus 10 squared equal to 100. Again, I apply a square root. Not necessarily b is 0. In this case, ready because you apply a square root here and a square root here. Is p plus 10 is equal square root 200. But square root 200, I know it's not perfect square, but you can break it down 200 like a 2 and 100. And the square root 2 is a prime, it stays the same, but the square root 100 is 10. So this answer is plus and minus, always plus and minus, 10 radical 2. It's no complex, it's no imaginary, but it's real, but it's irrational. Entonces, p alone is equal minus 10 plus or minus 10. Radical 2 and leave it like that. This is perfect answer. Okay? Okay, any question? This is hard, it's easy. It's easy. And this is extremely important. Extremely important. Quadratic equation, I promise. Okay, we study now. In the last lecture of this semester, when you are discussing a complicated thing, we are solving immediately of the process, one quadratic equation. Now you need to know very well. So when you face quadratic equation, you need to do fast in 2 seconds. Okay, another way to solving the quadratic equation is by completing the square. By completed the square. Method. Okay, let me try to explain. Complete the square. Suppose this example. X squared plus 4x plus 10 equal to 0. Suppose this quadratic equation. Okay, let me try to refresh your memory. One thing I suppose that you know, but maybe you don't remember very well, is the perfect square trinomial. Perfect square trinomial. Suppose this trinomial, x squared plus 4x plus 4. This trinomial is perfect square trinomial. Why? Because when you are doing the factorization of this, open 2 parentheses, the factorization is 2 and 2, because 2 times 2 is 4, and 2 plus 2 is 4, and plus. Wow! Therefore, they are twin brothers, and we can condense it like a 1 factor square. When this situation happens, when the factor is the same, this is called a perfect square trinomial. Okay, let me try another example to understand. X squared minus 10x plus 25. It's perfect square trinomial because the factorization is xx 5. Because 5 times 5 is 25, and 5 plus 5 is 10. In this case, minus, because the sign is minus. Therefore, the factorization is x minus 5 squared. And this is elegant, super elegant. But in our problem, we have, obviously, this is no perfect square trinomial. But you need to enforce it to be perfect square trinomial. How? Okay, look. You copy x squared plus 4x, and you move 10 to the right-hand side, like a minus 10. And you create, here I put one box. And inside the box, you put a magic number that convert this trinomial like a perfect square trinomial. Let's all look at 4. Okay, this is a magic number. Okay, you see before this example 4. I put artificially, totally artificially, to create a perfect square trinomial, this 4. In order to that same affect my original problem, I put 4 on the right-hand side in order to keep the equilibrium of the equation. Okay, now ready? This I know that the factorization is x plus 2 squared. Look at that here, like this, similar. And in the right-hand side, we have minus 6, because minus 10 plus 4 is minus 6. Okay, now I am ready to apply square root. X plus 2 is equal plus and minus I. Remember it's I because it's negative, radical 6. And 6, unfortunately, we cannot simplification anymore because 6 is 2 and 3. We have no couple of the factor. And leave it like that. So finally, solve for x is minus 2 plus and minus I radical 6. End the story. Maybe your question can flow in the air is, Professor, Well, they are formula to find the magic number. Of course, they are formula. The formula to find the magic number is b divided by 2 squared. This is the formula to find a magic number. Let me try. Go ahead. For example, in this example, can be a 4. 4 divided by 2 square. 4 divided by 2 is 2, and 2 squared is 4. Okay, magic. In this case, is 10 divided by 2 square. 10 divided by 2 is 5, and 5 squared is 25. Okay, this is the formula. You take b divided by 2 and square. Complete the square. I know it's a little bit complicated. I don't know if you remember or no, and you see before in your life. Do you understand? Yes or no? Don't worry, because I have 2 more examples. One easy and one complicated. Go ahead. Question.
Yes, thank you. I had a question about the Alex. Are we just supposed to be doing the assignments that you post up there?
I need question now of mathematics. When the class is over, you stay.
This is math, sir. I'm trying to figure something out really quick.
Come on.
Thank you.
Alex, I suppose you are signing inside Alex. Yes or no?
Yes, but I wanted to know if we also have to do the pie chart that it says to do with it.
No. I explained. No. I explained the last time. The only thing you should do, no pie. I am working different to another teacher. I create for you 2 homework, 1 pre-test and 1 test. You go to assignments and click in homework and start working on this. Okay?
No, thank you, bro.
Just in case, stay when the class is over. I explain detail. I open Alex. I share the screen for the Alex. I explain. I did that last class. But I understand that, first class, there are some problems. Some students enroll late. Okay? I don't know if it's your case or not. Okay, I need question about mathematics now. Do you understand very well complete the square or no? Yes. Okay, let's continue complete the square. Suppose this quadratic equation. Well, the same manipulation. I bring down x squared plus 6x. Okay, I move 18 to the another side. I try to introduce here a magic number that completes the square. Okay, let me try. Could you help me? And 9. She said get 9. Yulisa Valdez, 9. Where come from this 9? Well, remember, it's b, que is 6 in our specific example, divided by 2 squared. 6 divided by 2 is 3, and 3 squared is 9. And you put 9 here, and 9. And don't, in order to doesn't affect, you put 9. The factorization of this trinomial is x plus 3 squared. In the right-hand side, we have minus 18 plus 9 is minus 9. Okay, ready to apply square root both sides. X plus 3 is equal plus or minus 3i. Final is solve for x. X is equal minus 3 plus or minus 3i. End the story. Easy. Any question? This case is easy. No, Sabrina, no question. Good. Let's see, Sabrina, one more a little bit complicated. Suppose this 2x squared minus ax plus 5 equal to 0. This is more complicated. Why? Because the coefficient here is no 1. When the coefficient here is no 1 is 2. So it's a little bit, not too much, but a little bit complicated. So you, first of all, Okay, we are doing, for example, I move 5 to the other side. Let me try, step by step. 2x squared minus ax equal negative 5. Entonces, this is a moment to write the magic number, but no now, because I factor out, this is the new detail. You factor out these two out, and you have x squared minus 4x plus now is a box. Okay, minus 5 plus the box. But be careful, because this box not necessarily is equal to this box, because obviously the magic number is 4, no? We see before that one is 4 divided by 2 square, 4 divided by 2 is 2 square 4. But this number is not 4, because when you introduce 4 here, in order to create perfect square trinomial, actually this 4 represents 8, because 4 times 2 is 8. Okay, it's the only detail. Okay, now factorization is x minus 2, square equal 3, no? 8 minus 5, 3 divided by 2. You have divided by 2 here and divided by 2 here. Is because I want to isolate x minus 2 squared equal 3 half square root both sides. X minus 2 without a square is equal plus or minus radical 3 over radical 2. I apply the property, you know, when the radical involve the fraction, we can separate, no? And I don't know if you remember rationalization. Rationalization means eliminate any radical in the denominator. You multiply by radical 2, radical 2. This is working like a smart one again, but it's equivalent to say plus or minus radical 6 divided by 2. Because radical 2 times radical 2 is 2, and radical 3 times radical 2 is radical 6. So the final answer then is solve for x. Is x is equal, I move 2 plus or minus radical 6 over 2. This is perfect. However, I like to manipulate a little bit. Guys, in algebra, there are many ways to express one answer. And these are equivalent. It doesn't matter if you leave it like that, you have 100 points. If you, for example, condensing in only one common denominator, que es 2, es 4 plus or minus radical 6. Okay? It's equivalent. Either way. I don't know why I like this, but this is perfect. Okay? Super. Professor, you lost me in the magic number part.
I have a question.
Go ahead.
I'm confused about how you got 8 on one of the boxes.
Okay. The formula is b over 2 squared. This is a formula that allows us to find magic number. Okay. Do you understand the necessity of the magic number? Yes or no?
More or less.
More or less, no. You understand 100% or 0%? More or less do not exist. Okay, suppose x squared plus 6x plus something. I need this entire trinomial to be perfect square trinomial. Okay? So it's 6. You take 6 as b. 6 divided by 2 is squared. 6 divided by 2 is 3. Square is 9. Entonces, this magic number, you have to introduce artificial S9. And when you are doing this, amazing suddenly happen that this trinomial become like x plus 3 squared. Okay? Because the factorization is supposed that you don't know, open two parentheses, is 3, 3. Why? 3 times 3 is 9. 3 plus 3 is 6. And the sign is obviously plus. They are twin brothers, and we can condense it like that. You need another example to understand or no?
The thing is, I'm confused about on top where you put it was like 2x squared minus 4x plus 4, which was an imaginary number. I mean the magic number, and then it's equals negative 5 plus 8. How did you get the 8?
In what example? This.
That
Okay. Okay. Now I understand your question. Super, super. I understand your question. Because in this specific example, miss, you introduce 4. So the formula give me 4. But this 4 is inside this parenthesis. And you have a factor 2 outside. And 2 and 4, 2 times 4 is 8. So you introduce inside the parenthesis 4. Actually, the thing we are doing is introduce 8 because 4 times 2 is 8. Okay? Okay? Yes or no, miss?
yes, thank you.
Okay. Okay, guys. I know the time is over.